equations. And in the system of linear equation, we talk about the matrix method to solve the solution of the system linear equation. So for example, in the system of linear equation, we have like, for example, a x1 plus b x2 plus c x3 is equal to, let's say it is L, right? And then you can say that let's say ABCD x1 plus E x2 x3 is equal to M, and then G, H, and I, x1, x2, x3. So we have the system of linear equations like this one. So what we're gonna do, we're gonna apply AX, x is equal to A inverse into B. We will apply this rule, and then first we will find the A inverse by adjoint of A divided by determinant of A. Find A inverse and then put the value into here, A inverse into B. This will give you values of x1, y1, and x1, x2, and x3. Okay, so this method is known as matrix method to find the system of linear equations. Right? And next, there are other two methods. First is Gauss-Jordan method. And then there is another method which is known as Gauss elimination method. Today we're going to talk about this one and this one. We already talked about this one. This is very simple method. This was very simple formulas in this method we already used, and we will solve another example later on about this one. So for now, let's talk about the first method, the second method first. We're going to talk about the Gauss elimination method, and then we're going to talk about the Gauss-Jordan method to find the solution of the linear equation. So in here, let's see, we will go with an example. Example number 1. Okay, in here, solve the following equation using Gauss elimination method. What is Gauss elimination method? This is a simple rule. We will have the equation like, let's say we have 10x1 minus x2 plus 2x3 is equals to 4. And then the second equation is x1 plus 10x2 minus x3 is equals to 3. And then we have another equation, 2x1 plus 3x2 and plus 20x3 is equal to 7. We have this equation. And we have to find the x1, x2, and x3 in this equation using the Gauss elimination method. And this method is known as partial pivot method. This is the second name. Sorry, partial. This is partial pivot method as well. Okay, so this method is also known as partial pivot method. And what we're gonna do in this one, so most of the time we are interested in one thing. So we will write down our matrix like this one. This one is matrix 10 minus 1 2, and then 1 10 and minus 1, and then 2, and then 3 and 20, and then make it like this way, or you can just put it at line and then put the matrix B in here. And the matrix B here is 4 3 and 7. Okay, so this matrix is named as augmented matrix. How you gonna make the augmented matrix? First, you will take the coefficients of each of the equation in here, equation number 1, equation number 2, equation number 3. Take the coefficients in here by rows, write down it here, and then the coefficients of your matrix B, and put it in there. So this matrix is known as augmented matrix. So in first step, in step 1, okay, let's say this is step 1. This was step 1 to make the augmented matrix. And in step 2, we have to apply the column or row operation. Row, column operations. We already talked about that we can change two rows, like row 1, row 2. We can interchange them. We can also subtract any row, multiply a row with a number and subtract it with another one. We can interchange, or we can just multiply a scalar with any of the row. Okay, so it's not necessary to, let's say I write it 2 1 whatever, but it can be any row. Okay, so these 3 1 2 3, these are the 3 operations that we're gonna apply on this one to find the solution. Okay, so I hope this thing is clear. So basically what we want to find the solution of this one, and to get the solution of this equation, our main objective is to make it 0 and 0 and 0. We have to make these 3 elements 0. Right? For example, if I make these 3 elements 0, like for example, after operation, the row or column operation, it will be like, let's say it is 2, it will be 0, 10, minus 1, 0, 0, 20, let's say, and then this one will be 4, 3, 7, right? So our equation, it will become 10x. Our equation will become 10x 1 plus, minus x2 plus 2x3 is equal to 4. And then this equation will become 0x1 plus 10x2 minus x3 is equals to 3. And finally, this equation will be 0x1 plus 0x2 minus 20 plus 20 x3 is equals to 7. So from here we will find x3 is equals to 7 by 20. If we know x3, then put this value x3 in here, find x2. When we have x2 and x3, put the value in here, and here find the x1. Okay, so this is the main agenda of this technique, that we have to make this one 0 by applying the row or column operations. Okay, so let's start in a practical way. Let me try to remove it. Okay, so most of the time, let's see, the solution. So in first step, there is a technique. You have to understand the technique that you have to make this one in the second step. You have to make this and this to 0 using this one. Using this element and this element equal to 0 using equation number, row number 1, right? So for this one, you can apply many things. So what I'm gonna do, I'm first gonna change R1 and R2. What I will write it in this way: 1. This one is R2. This one is R3, and this one is R1. What I'm gonna do, change R1 to R1. I will tell you why I change it later. So it will be 1 into 10 minus 1, and it will be 3. And then it will come here 10. It will come here down. This is minus 1. This is 2, 4. And finally, I will have 2, 3, and 20, and then 7 in here. So I apply an operation in here, and operation R1 changed into R2. I interchanged both of them. Okay. So in my next operation, what I'm gonna write, let's say this now the argumented matrix is 10 minus 1, 2, 4, 1, 10 minus 1, 3, and 2, 3, 20, 7. So it is up to you. You can put full line or this one, whatever you want. It's up to you. Okay. So this is in the second operation. What I'm gonna do, I have to make it this one and this one 0. How can I make it 0? So always keep in mind, you have to make this row 2, and row 3 equals to 0 in this one and this one using R1, right? How I'm gonna do, I will say R2 is equals to R2 minus 10 R1. Let's see if I apply this operation in here, so how my this matrix will look like. So in here I will say R2 is equals to R2 minus 10, because I have to make this element to 0, right? So what I'm gonna do, I will make R1, 10 R1. No, it should be R2 is equals to R2 minus, sorry, 10 R2 minus R1, right? Okay. So what I'm gonna do in here is that I multiplied this row with the 10, right? So, and minus into R1. So how it will look like? This will be equals to this one and this one. So multiply it with the 10. It will be 10 minus 10, right? So this equation will be equals to, first it will be like this one minus 1, 2, 4. So there will be change in R2, right? So if there is a change in R2, then how it will look like? It will look like you multiply it R2 with multiply R2 with 10. So I multiply, it will be 10. 10 minus 10, it will be equal to 0. So I multiply R2, this is 100. This is, what is this? This I multiplied R2 with 100 minus minus 1. So it will be equals to 1, 0, 1. I multiplied this one with this one. Okay, 10 R2. Okay, and then again I 10, this will be equals to minus 10 minus 10 minus R1. R1 is equals to, it will be minus 12 is equals to, again multiply it with the 10, it is 30 minus R1. R1 is equal to 4, it is equal to 26. Right? You can do it in this way. And similar way, in a similar way, this one was 2, right? So what I'm gonna do, 2, I will multiply it with 5. My row operation will be R3 is equals to multiply this one, multiply this one was 2, okay. Multiply it with 5 R3 minus R1. You will see we are using R1s. We are using this row to make this one and this one equal to 0, right? So if I multiply this one with 5, so it will look like 10, 15 multiplied by 100 and 7, 35. This row will look like, because I multiply, and I will have to minus it with R1. It will be 10 minus 1 minus 2. This will be minus 1, it will be plus, and then multiply it with, this will be 4 minus 4. So it will be 0. So it will be 0, and this one will be 16, and then 0. This will be 16, and this one will be 98, and 98, and then this one will be 31. Is it clear? Do you have, if you have any question, please send me the text or just tell me. Okay, so now we have this one. Now we have to make this one 0 using row number 2. Okay, do you know how we can make it 0? I want to make it 0. How I will make it? Anyone can give me idea? I want to make 16 0 using R2. Anyone can give idea? So we have to apply operation in R3, right? So my R3 should look like there is 16 and there is 100. So we have to 10 R3 minus R1. So this one should be 0. So I have to multiply with a common factor. So you know how to make the common factor, the least common factor of 100 and 101 and 16. Anyone know? 3. Let's find the least common factor of 16. Okay, let's just multiply it with this 16. 16 multiplied by 101. Okay, 1616. Okay, so multiply this one with 16 and multiply this with 101. So what I'm gonna do, R3 will be equals to 101 R3 101 R3 minus 16 R2. Always remember we have to use R2. We will use R2 to make it 0. In this step, in the first step, we use R1 to make those 0. Now I have to make this 0, then I have to use, I have to make this one 0, then I will use this one. Okay. So the one I cannot use in here R1. I cannot use R1 in here. So if you will put like this way, so for example, 101 R3, so it will be 0, 0, and 116 into 101, right? 98 into 101 and 31 into 101, right? We have this one. And then 16R2, 16R2, 0, and then it will be 101 into 16, and this one will be minus 12 into 16, and then this one will be 26 into 16. So we will subtract it. This one gone, this one gone, and then the remaining one will be 98 minus into, let me calculate. Can you just calculate this one? How much is this one? I will also double check. 98 into 101. This one is minus and minus plus 26 into 16. It will be 10, 3, 1, 4. This one 0, this one will be 0, and then finally this one 31 into 101 minus 26 into 16. It will be 27.15, right? So my this one will be 10 minus 1, 2, 4, 0, 101 minus 12, 26. Then this 0, 0, 1, 0, 3, 1, 4, this one, and 2, 7, 1, 5. Right? So now I already made this one triangle. This is 0. Right? Now I can, let me try to raise it. Okay, so now I made this one. So my equation will be 10x1 minus x2 plus 2x3 is equals to 4. Then 101 x2 minus 12x3 is equals to 26, and 101,314x3 is equals to 2715, right? And from here x3 will be equals to, let me divide 2715 divided by 101,314. It is equals to 0.02 x3. If you put x3, the value of x3 in here, so 101 x2 minus 12 into 0.02 is equals to 26, or 101 x2 is equals to 26 plus 12 into 0.02 equals 0.24. And then you can say that x2 is equals to 20 plus 26 divided by 101 is equal to 0.25 x2. We have x3, and then put this value in here and this value in here, and then finally 10x1 minus x2 is equal to 0.24, 0.25, and plus 2, what is x3? x3 is equals to 0.02 is equals to 4. So 10x1 is equals to 4 plus 0.25 minus 2 into 0.02. So let me solve it. For x1 is equal to 4 plus 0.25 minus 2 into 0.02 divided by 10. Okay, so my answer will be 4 plus 0.25 minus 2 into 0.02. So it will be like 4, okay, divided by 10 is equal to 0.421. So x1 will be 0.421. Okay, I go on instead of sir, I think it's okay. It's 1000 in here. Okay, so okay, just check this one. Maybe this one is the error. So it should be 16 multiplied by 101. 16. Okay. So anyways, in any case, just try to learn the method. This is the method that how we gonna solve it. Okay. So let's try to solve another example so it will be more clear to you, and we can have, okay. So in our next example, they give us the matrix, like matrix is 1, 2, 3, 4, 7, 10, 5, 2, 7, 10, 5, 2, and then 13, 6, 2 minus 3, and then 11, 14, 8 minus 1, and then the value of this one x1, x2, x3, x4 is equals to 10, 40, 34, and 64. So in the first step, we have to make the augmented matrix. So augmented matrix will be like, right, the matrix will look like this one. 1, 2, 3, 4 dots, 10, 7, 10, 5, 2 dot 40, and then 13, 6, 2 minus 3 dot 34, and 11, 14, 8 minus 1 dot 64. Okay, so in this case, we have to use R1. We have to use R1 to make this, and this 0. Okay, again, we have to make these elements 0. We have to make these elements equal to 0. So to make these 3 to 0, we will use R1. To make 0 to these 2 elements, we will use R2. To make this one 0, we will use R3. Okay, is it clear? So let's try our first thing, that we will make this one, and this one equals to 0. So for example, if I apply, let's say this one is 7. If I want to make this one is equal to 0, so my R2 will be equals to R2 minus 7R1. Is it clear? Right? If I want to make it 0, so what I am going to do, I will multiply my row 1 with 7 and subtract both of them. Then my new row will be this one. So if I want to make this one 0, what I am going to do? Can anyone tell me what will be R3? Any one of you can tell me what is R3? Anyone? Anyone can tell me, please? Yes, R3 is equal to minus 7R1. No, R3 is equal to minus 3. R3 minus 13R1. It should be the correct. Okay, R3 minus 13R1. And then if I want to make this 0, what I'm going to do, R4 is equals to R4 minus 11R1. You can see we subtracted the first row from all of this operation. Okay, so let's try to make it one by one. So there will be no change in the first row, right? So I will write the first row like 1, 2, 3, 4 dot 10. Okay, now we have to multiply, we have to do this operation. So R2 minus 7R1. R2 is equal to 7 minus 7. It will be equals to 0. 10 minus 14. 10 minus 14. It will be equals to minus 4. And then 5 minus 21. Can anyone tell me what it will be? Minus 16. And what is next? What will be the next? Minus 26. Great. And then what is this value? Minus 30. Okay, great. Okay, that's great. And now tell me this value. What is this value? Now we're gonna go with this R3. So this value will be 0, of course. And then what is this value? What is this value? We have to apply this row one. So 13 multiplied by R1, 26. This is 26. So 6 minus, yes, minus 20, correct. And what is the next here? Minus 37. What is next? Yes, minus, and then what is this one? Minus 55. And then here, minus 96. We have 3 rows, and the final in here, it will be, of course, it will be 0. And then in here, minus 8. And then, and what is this value? Minus 25. Great. And next, tell me quickly. Minus 45 is equals, not equals, and then final this one, minus 46. Correct. So now our first thing is done. We made it this one, and this one equal to 0. Now our next objective is to make this one and this one equals to 0 using this row. Okay. Again, we have to make this one and this one equals to 0 using only this one, only this row. Okay, so let's try. I will remove this one and then okay. Now anyone can tell me the operation, what should be operation, because now this first row and second row, it will be same. So I will write first and second row. 1, 2, 3, 4, 10. And then 0, minus 4, 16, minus 26, minus 30. This will be the same. Now the changing will be in this row and in the next row. So for example, can anyone tell me what should be R3 now? R3. I have to make this one 0. Can anyone tell me? R3 will be equals to R3 will be equals to, yes, R3 minus 5R2, right? We can put this one. Okay, let's try to solve this. Try to write R3 in here. Okay, then R3 will be R3. This one 0 minus 0, it will be 0, and this one will be 0 as well, right? This both will be the 0. And what is the next in here? Anyone can tell me? In here, what will be in here? 43, correct. And what is the next? What will be the next? R3 minus 5R2, 75. Great. And then in here, R3 minus 5R2. How much? 54. Okay, and next our step is making this one. We make this one. Okay, so we made using R2, and okay, so we have to make this one. So how we will make this one? R4 will be equals to what? R4 is equals to 2R2. R4 minus 2R2. Great. R2 or R4 minus 2R2. So it will be 0, it will be 0, it will be 0 as well, right? And then what will be this value? This value will be 7. And we are going right way. This one. Okay, wait. We made this one. First, we make this one 0, and then we make this one 1, 2, 3, 4. Sorry, it should be. This is sometimes really confusing. Okay, again, in here we make R3 is this one, and R4 is equal to this one, R3 and R4. So it should be 0, 0. Yes, 0, 0. Yes, it should be 0, 0. And in here, it should be, sorry, it should be 0, 0, 7. And then, no, 0, 0. Oh, it's so confusing. 0, 0, 7. And then it should be not 7. Let me write. R4 is equal to R4 minus R4 is equal to R4 is equals to minus 45 minus 2 into 46 minus and minus should be, and it will be, let me calculate with my calculator. It will be equals to minus 45. Oh, it is 7. It should be 7 in here. 7, and then what should it be in here? 14, right? So we have now in our last step, I will just raise this one, and our last step is Okay, so in our last step, we have to make this one we have to make this one equals to 0 using R3. How are we gonna make it? So in here, we can write it. There will be change only in R4, right? So I will write 1, 2, 3, 4, and 10. 0 minus 4 minus 16 minus 26 is equal to minus 30. And then it is 0, 0, 43, 75, and 54. And finally, this one was 0, this one. Okay, so in here, we have to apply this one. So in my opinion, R4 should be equals to, this is 7, 43 by 7 by 43. Okay, so it will be equal to R4 minus 77 by 43 into R3. If I write in this way, so let's see, 0 minus 0 minus 0, 0, 0 minus 0, 0, and we multiply it with R4 with, I think, yes, it should be 43. It should be 43. It should be, R4 should be 43, and it should be 7. It should be like this way. Okay. So we will multiply, it will be 0, and then what it will be? Can anyone tell me? What it will be in here? Minus 224. Okay, minus 224, minus 224, and final in here. Yes, plus 224. Okay, so now we made these three, 2, and this one. So we make a rectangular, this one. So this matrix will, you can say it, upper triangular matrix. So we have already this one, and then now we can say that minus 224 x4 is equals to 224. So it means x4 is equals to minus 1, right? We have x1, and then in next one we can say that 43 x3 plus 75 x4 is equals to 54, right? We have the second equation. So putting the value for x 43 x3 plus 75 x4, what is the value of x4? It is minus 1, is equals to 54. Sorry, 54. And then putting the value 43 x3 is equals to 54 minus 75. Sorry, this is minus, so this will be plus 75. X3 will be equals to, x3 is equal to 3. Okay, so there are two students. They are saying okay, x3 equals to 3. Yeah, x3 is equals to 3, correct? I checked it, and x3 is equals to 3. Similarly, you put the values of x3 and then find the value of x2 and then value of x1. So your final answer will be, I will just write x1 is equals to 1, x2 is equals to 2, x3 is equals to 3, and x4 is equals to minus 1. This will be your final answer. Okay. I hope this thing is clear to everyone. And we can solve another example. I want now everyone please participate in it. So I will not write, you guys will help me solving this one, okay? So the students who are participating in the class, for sure they will get the bonus points, okay? So please participate in the class. Okay, so next question is our example number 3. In example number 3, let's try to find for the matrix 2, 0, 1, 1 minus 1, 1, 4 minus 2, 3. And this one is x, y, z is equals to 3, 1, 3. So first step is, in our first step is, we will write augmented matrix. Augmented matrix will be 2, 0, 1, 3, 1 minus 1, 1, 1, and 4 minus 2, 3, 3. Okay, so again, make this one and this one equals to 0 using this one. So how can we go? Anyone can give me suggestion? Okay, so I would say I will put operation in here. I have to make it 0. So so what should, for example, if I interchange this one with this one, so it will be more easy. For example, I will just change R1 and R2. Let's change R1 and R2, right? So my matrix will be 1 minus 1, 1, 1, 2, 0, 1, 3, and 4 minus 2, 3, and 3. Right? I just interchange it. So now it will be easy for me. For example, if I want to put the operation, I would say R2 is equals to R2 minus 2R1, right? R2 minus 2R1. We can, yes, we can write it. And then R3 will be equals to R3 minus 4R1, correct? So if I put this operation in here, so my augmented matrix will be 1 minus 1, 1, 1, and then my augmented R2. So in here, what will be the R2 in this one? Of course, it will be 0 because we want to make it 0. And then how about this one? 2. Let me, okay. So this one will be 2. What is the next? Okay, in here, what is this one? Minus 2 or what? There is different opinions. Minus 1, 2, minus 1, 2. Okay. Okay, I will calculate them. Okay. So in here we have to R2 0 minus 2 minus 2. Sorry. Wait. No. I have R3. Okay, we are talking about this operation. Okay, 0 and 2 and then -1. It is -1. Okay, yes. And then this will be equals to 1. And then if we go here, this will be 0, this will be 2, -1, and this one, and -1. It would be like this way. And then if I have to make this one, I have to make this is equals to 0 using wrote this one. It is simple. R3 is equals to just minus it. If we just minus it, then we can find it. R3 is equal to R3 minus R2. Right? We can write in this way. So once I make this one, my matrix will look like 1 minus 1, 1, comma 1, 0, 2, -1, and this one 0. This minus is R3 minus R2. 0 minus 0, 0, 2 minus 2 is 0, -1 minus -1, it will be equals to -1 minus -1. It will be equals to 0. Oh, 0. And then this one, what it will be. Okay, sorry. And this is equals to -2. Okay. So do you think it is possible? Do you think it is possible? For example, now we have a thing 0 is equals to -2. Is it possible? Like if we make a question from here, okay, so the three questions from here, it will be like, okay, so 1, so it will be equal to x minus y plus z is equals to 1. First equation from here. Second equation will be equals to 2y minus z is equals to 1. And the last will be equal to 0 is equals to -2. This is okay, but do you think it is possible? Yes, it is not possible. So whenever you get this one, you will say that this system of linear equation, they don't have solution. So you will write no solution. Some system of linear equation, they don't have a solution. So 0 is equals to -2, which is impossible. So the given system of linear equation has no solution. Okay. Okay, so let's try to solve another example. So we will have, so in our this equation number 2, when we solve, we find a finite solution, and in example number 1 as well, we find a finite solution. But sometimes there are no solution as well, and sometimes there is infinity solutions as well. So let's try to solve another example, and let's see. Okay, so they say that we solve the system of linear equation, and in the system of linear equation, they already give us the augmented matrix only. So let's try 4 minus 3 minus 9 and 6. And then 2, 3, 3, 6. 4 minus 21 minus 39 and -6 and and the accumulated matrix is 0, 6, 24. It will look like it is not a square matrix. Okay, it is not a square matrix. So let's try to make it first this one 0 and then this one 0. Then you will feel like if we make this one equals to 0, but still we will have this one and this one, right? This we will still have. So then we will have 1, 2, 3, 4, 4 unknown, and we have only 2 known values. We will have only 2 known values. So if this case happen, then the system of linear equation has infinite solution. Okay, so in that case you can still solve it. For example, if you put the first operation in it, like R2, this one is here, so you can just multiply it with 2. R2 is 2R2 minus R1. You can put this operation, and in here R3 is equals to R3 minus R1. If you put this one in here, then you will get some values in here, and for example this one and this one will become 0, and in next step this will become 0, but still you cannot make those two things equals to 0. So you will just, after one time, you will just say, okay, this system of linear equation has infinite solution, so we cannot solve it until unless. Yes, if it is not in this one, so it means we cannot find the solution. Okay, so because this is like quite visible. Like for example, the equations, I have this equation, second equation, and third equation. I have 3 equations. So if I want to solve system of linear equations, if there are 3 equations, there should be 3 unknowns. But in here, there are 4 unknowns. If I have one more equation, then I can say that, okay, so this system of linear equation can be solved, right? So because there are 4 equations and 4 unknowns. When there is 4 equations and 4 unknowns, we can solve it. But if in this case there are 3 equations but 4 unknown values, right? Once there are 4 unknown values, we cannot solve it. We need one more equation. Yes, it will be same will be applicable in 4×2 matrix as well. Once it is not a square matrix, you cannot find the solution until unless it's a square matrix. Okay, so this is a basic rule, like x1 plus x2 plus x3 is equal to, like, say 3, and then x1 plus 2x1 plus x3 is equal to 7. You cannot solve this system of linear equation because you need minimum 3 equations to find the solution. With these 2, you cannot find it. But if you have one more, x1 plus 7x2 plus 3x3 is equals to 10, then you will say, okay, I have 3 unknowns, these 3 unknowns and 3 equations, right? So now I can solve it. Okay, so this was about the Gauss elimination method, and then I hope this thing is clear to everyone. And and this one was Gauss elimination method with the partial pivot method. So let's try to solve another method which we call the Gauss elimination, but with complete pivoting. Okay, so there is example number 4 or 5, whatever. So they say that solve the system of linear equation using coordination method with complete pivoting. Okay, so it is easier than the previous one. So what for example, we have system of linear equation 2x plus y plus z is equals to 10, and then we have 3x plus 2y plus z 3z is equals to 18, and then we have x plus 4y plus 9z is equals to 16. Okay, we have these three system of linear equation. So in this one, the first step one. In step one, you have to see in which value of x you have to solve first x, then y, and then z. Okay, so the absolute value of largest coefficient of x is equals to 3. You have to see this one, and this one. Okay. You have to see the coefficient first. In x, the largest coefficient is equation number 2 for the equation number 2, right, which is equals to x. So you will find the value of x from equation number 2 and put in the other two equations. Okay, so let's say from equation number 2, okay, so from equation number let's say this is your equation number 1, this is equation number 2, and this is equation number 3. Okay, so what we can do in here, we have to divide equation number 2, divide equation 2 by 3, right? Because if we divide this one, we can get the value of x, right? So if we divide this one, 2 equation number 2 divided by equation number 3, so the value will be, you can say that x will be equals to minus 2 by 3 is equals to, okay, x by this one, 2y by this one. Wait, three. Okay, so question 2 and 3, so it will be equals to minus 2 by 3y minus z plus 6. You guys know what I did in here? Just divide equation 2 by equation 3. Just find the largest and the lowest x coefficient. Once you have it and you have equation number 4 in here, right? So from equation number 4, you have x value. Put the value of x into equation number the equation number 1 and 3. Put the value of x in equation number 3, or there is another way. How can I say? Wait, erase. Instead of this one, just do this one. The largest value in here, 3x plus 2y plus 3z is equal to 18, and then just divide it by 3, and then it will be x plus 2 by 3y plus z is equals to 18, and then x will be equals to what? X, sorry, 3, and x will be equals to 8 minus 2 by 3 minus z plus 6, right? Now you have the value of x. Put value of x in equation 1 and 3, right? From equation, which in first step you have to choose the coefficient. We choose the coefficient x, and then in x coefficient we have to see what is the largest value. The largest value is in equation number 2, and then get 18 here and find the value of x. Now you have a value of x. Put the value of x in here and put the value of x in here. Okay, let's see. Put the value of x in here. So our equation will become 2. This one is equal to minus 2 by 3 y plus, sorry, minus z plus 6. So put the value of this x will be go in here. So 2, the value of x in here, plus y plus z. So 2 into this one was x plus y plus z is equals to 10. So if you will solve it and try to simplify it, it will be 1 minus 2, take the common, 4 by 3, and then it will be equals to y minus z is equal to minus 2, and then further solve it. So okay, so if you further go with it this one, let's say this is equation number 1, 2, 3, 4. Let's say this is equation number 5, and then from equation, the other equation, it will be equals to minus 2 by 3y minus z plus 6 plus 4y plus 9z is equal to 16. And then again simplify it, and then you will get the value. After simplifying it, you will have 10 by 3y plus 8z is equals to 10. Or you can also simplify the equation number 5 in here, and in equation number 5 will be equals to y plus 3z here minus 2y plus 3z is 6. You have this equation number 5. This is equation number 6. Right? Now you have two other equations. And then you will eliminate the value, sorry. Okay, so now you will eliminate the y. So now equations are y plus 3z is equal to 6, and the other one is 10 by 3y plus 8z is equal to 3 is equal to 10, right? So which coefficient is larger? This one, right? So now find the value of y from here and put in here. Okay, let's see. It will be equal to 10 y plus multiplied by 3 everywhere. It's 8z. 4z is equal to 30, right? And then if I want to find the value of y, it will be equals to 30 minus 24z divided by 10. Put the values in here, right? So value will be equals to 30 minus 24z divided by 10 plus 3z is equal to 6. And then from here, if you try to solve it further, you will see you only have z in here now, right? So simplify it and solve it, then this value of z will be equal to 6. If you have value of z, then put the value in here. Y plus 3 into 6 is equal to 6. Y is equals to 6 minus 18 is equal to minus 12. 6 minus this is equals to, yeah, like this one. And then put the value of y. You have value of y and you have value of z. Just put in here and define the value of x as well. Okay, this one is easier method compared to the partial pivoting method. And yeah, so when it is mentioned over there that you use the complete pivot method or use the partial pivot, so you have to do as described. But if they say that just find a solution of the linear equation, system of linear equation, you can just use any method. You can use the matrix method, partial pivot method, or you can use complete pivot method as well. Okay. Is it clear to everyone? So any question? Okay, let's try another example. So we will have a clear, okay, so let's, okay, so in other example, we have equations like 10x plus 2y plus z is equal to 9. The other equation is 2x plus 20y minus 2z is equals to 44 minus 44, and the third equation is minus 2x plus 3y plus 10z is equals to 22. Okay, so we will eliminate the variables first. In first step, we will eliminate x. In second step, we will eliminate y, and then the third step we will eliminate z, define the value of z, and then put back over there. Okay, so first I will eliminate the value of x. Eliminate x. To eliminate x, I have to see the absolute value of the coefficient of x. The absolute value of the coefficient of x is larger in here, right? So I will find the value of x from this equation. This is equation 1, this is equation 2, this is equation number 3. So I have to eliminate the x. So which equation I will use? This, or this? So because the coefficient with the x is larger in here, so I will use equation number 1. So if I will write 10x plus 2y plus z is equals to 9. Or I can say that 10x is equals to 9 minus 2y plus z. Or I can say x is equals to 9 minus 2y plus z divided by 10. This one will be minus as well. So this one will be the value of x. Or you can further x is equals to minus 1 by 5 y minus 1 by 10 z and plus 9 by 10, right? So I have now equation number 4 here. Now this equation number 4, I will put the value of equation number 4 in equation number 2 and 3 one by one. Put value of x from equation number 4 into equation 2 and 3. Equation 2 and 3. Okay, so let's put the value in here. So it will be equal to 2. What is the value of x? X is equals to minus 1 by 5 y minus 1 by 10 z plus 9 by 10 plus 20y minus 2z is equals to minus 20, right? So this will, let's try to simplify it. If you try to simplify it in this equation, you will see your final equation will be equals to okay, let's try to simplify by ourselves. It will be equals to minus 2 by 5 y minus it is cancelled in here 1 by 5 z plus this is cancelled in here, so it will be 9 by 5 plus 20y minus 2z is equals to minus 44. Try to simplify it, take LCM, and then you will see that your final answer will be 98 y minus 11 z is equals to minus 229. So this will be your equation number 5. And then there will be another equation by putting the value of x in equation number is 3. Equation number is 3. So it will be equals to minus 2. What is the value of x? Value of x is equals to minus 1 by 5 y minus 1 by 10 z plus 9 by 10 plus 3y plus 10 z is equals to 22, right? So put the value minus 2 by 5 y and minus plus it will be equal to 1 by 5 c plus 9 by 2 9 by 2, yeah, 9 by 5. This will be minus, this will be plus 3y plus 10 z is equals to 22. So once you will simplify, you will see that the answer will be 17y plus 51 z is equals to 119. So this will be equation number 6. Now you have to eliminate the value of y. So for elimination of the y, you will use this equation and this equation. So where the coefficient of y is larger in equation number 5. So using equation number 5, 5, find y. Okay, so question number 5 using 5y. So put y will be equals to it was 98y, so it will go there 11 by 98z minus 229 divided by 98. So this is the value of y. So let's say this is 7. So put the value of y in the equation number 6. Put y from equation 7 into 6, right? So we have 17y is equal to 11 by 98 z minus 2 29 98 11z minus 51z plus 51z is equals to 119, right? So now solve it, and once you will solve it, you will see the value of z will be equals to 3 if you solve, because you only have one unknown which is equal to z, and everything is known, and then you will find the value of z. Once you have value of z, put the value of z in equation 7, find the value of y, and once you put z here, so you will see the value of y will be equals to minus 2. So now you have y is equal to minus 2 and z is equal to 3. Put these values in either in equation number 1, 2, or 3. You will get the value of x, which will be equals to 1. Okay, z will be equals to. Okay, so this is the thing that I think this one is easier, but it is lengthy, but it is easier to understand. Yeah, okay, no worries. So yes, the value of z was 3. Okay. So any question regarding this one? Any other question? Any confusion? Okay, so now the methods should be really clear. Number one method was the matrix method. It should be clear that how you use the matrix method. In matrix method, you will find the adjoint of A and determinant of A. In Gauss elimination method, what you're gonna do, you will give the partial elimination by applying the rows or the column operations. And finally, in this one, the last one, we find the Gauss elimination method with the complete pivoting. What we use, we eliminate first x, then we eliminate the y, and then we eliminate the z and find the value of z at the end, and then go back, find the value of y and then x. Okay, and then that's it, that's the solution. Okay, so I repeat again, if in the question, in the final exam or the midterm exam, it is given that just solve this one, you can use any of these methods. But if it is mentioned, use this particular method, then you have to use that particular method to solve the system of linear equation. Okay, so finally, we have another method which we call the Gauss-Jordan method, and then let's try to solve Gauss-Jordan method as well. It is easier as well, but you have to use the row and column operations as well. Okay, so let me find the Okay, so the Gauss-Jordan method and the elimination method, these are almost same, but the only difference is in Gauss elimination method, for example, if we have this one values like in here A, B, C, we make it 0, and D, C, D, and then E, and then 0, and then F. We make it this one, right? But in this one, we have to make this, there must be two zero triangles. Okay, so one triangle here and one triangle here, it should be 0. Okay, I hope this thing is clear. So when we will make this one 0, we will use this row. When we will use make 0 to these two elements, we will use this row, and then when we will make these two elements 0, we will use this row. Okay, so this method, this is the current method is Gauss-Jordan method. The previous one was Gauss-Elimination method with complete pivoting. And the previous one before this one, Gauss elimination method with partial pivot. Okay, so this one are almost same, because in this one Gauss elimination method with partial pivoting, then we use this triangle 0. But in here we have to make these two triangles equals to 0, and then this will be your Gauss-Jordan method. Okay, so let's try to solve this one, and I will just erase it. Okay. Okay, so let's say we have a system of linear equation in here. So the system of linear equation is 2x1 plus 8x2 plus 2x3 is equals to 14. The second system of linear equation is 6x1 plus 6x2 minus x3. And then finally we have is equals to 13. And finally, we have the last one is equal to 2x1 minus x2 plus 2x3 is equals to 5. So first, second, and third equation. Same method, make the augmented matrix. So let's make 2, 8, 2, 14. And then 6, 6 minus 1 and 13. And then 2 minus 1 and 2, and this one is equal to 5. Okay, so again start from making this one and this one 0. Okay, so how you gonna do this one? I have to make this one and this one 0. So I will say R2 is equals to R2 minus 3 R1, right? Is it clear? And then if I want to make this one 0, what I'm gonna do? Can anyone tell me R3? What will be the operation in here? Anyone? R3 minus, yes, R3 minus R1. Sorry, R3 minus R1. Okay, yes, R3 minus R1. Okay, so once you will apply this rule, you will see your matrix will be, for example, after first row there will be no change, 2 8 2 14, right? And then it will be 0, and then I have 3, it will be equal to 14 minus 18, and then it is equal to 3 and minus 3 plus 2, and it will be equals to minus 7, right? It will be equals to minus 7 and 3 or 1. And then what else? What it will be? Can anyone? 3 or 1. 14 threes are 42. 14 are 42 and minus, and it will be minus 42 plus 13, it will be equal to 29. Minus 29, sorry, minus 29. And in here, in the last one, it will be equal to 0 and minus 9 and 0, yes, and minus 9. It will be like this one. Okay, now in our next step, I have to make 0, this one and this one 0. Okay, I have to make this one and this one 0. How I'm gonna do this one? Anyone? I want to make this one and this one equals to 0. How? Using this one. So what I'm gonna do, I will just this one is minus, so I will multiply it with R3 will be equals to, this minus is R3 minus no, I will use 2R3 minus R2. Yes, correct. Yes, correct. Okay, so this is correct. And then for this one, what I'm gonna do for this one, if I want to make it 0, then how I using this one, how I'm gonna do this one? Anyone can tell me? No, but then it will become this one. So let's just apply this one, this rule, just apply this one, and let's see what will happen. Just apply only one one of this one, and then we can interchange it later. So once we apply this one, this rule, it will be 2 8 2 14, and then it will be 0 minus 18 and minus 7, it will be minus 29, and then this one will be equal to 0 0, and just it will be equals to 2R3, this one minus this one, it will be equal to minus 7. What's the value? Can anyone tell me? 7 plus 7. Okay, and then final in here, what it will be? Anyone? 11. Okay, 11. Great. So
Now we already made this one as 0. Now our target is to make these things zeros. Any idea how we can make this one 0? Any idea how how we can make it? R1 is equals to 8 by 18. Yes. Okay, so there was a good option. There, the one student, she sent me good option. R1 is equals to, I want to make this one 0. R1 is equals to uh, divide by 18, so it's eliminate 8. How? How about going in this way that R3 R1, sorry, R1 is equals to R1 plus 8 by 18 into R2. What if we do this one? R1 is equals to change will be in R1 plus this one. It will work. Okay, so if it is working, then our matrix should be look like 2 0 0. It is 0 0. Okay, and then we will make it 0, and then it will be minus 18, and then this will be your 0, and then it will be equals to, okay, this one will be equals to minus 10 by 9, this one will be equals to minus 7, and this one will be equals to 7 by 2, and then this one, okay, so in this one it will be equals to 10 by 9, this one will be equals to minus 29, and this one will be equal to 11 by 2. Sorry, it might not be 2, it will be just 11. Okay, so now it is already 0, and then we can just make it 0 with the help of this one. We can make this one 0, and either this one or this one, we can just make it 0. Okay, so again, it is sometimes very confusing. It is sometimes very confusing, but still we have to do several times and several times. So if we put on here in the next step, if we put the values R1 is equals to R1 plus 2 by 7 into 10 by 9 R3, then it will become 0, and then finally we can subtract this one, it will become 0, and then that's it. That's it. We will, okay, so after this one, then R2 will be equals to R2 minus 2R3. So it will make this one to equal to 0. So actually, Gauss-Jordan method is a bit what you can say, tricky. You have to be uh, very conscious while you are using this method. So once you have this one, then So after, let me show you your final matrix will be look like this one: 2 0 0 and 20 by 7, and then 0 minus 18, 0 minus 18, and then it will 0 0 7 by 2, 11 by 2. So now it is equals to what was it is x1. Okay, it one x1. So in here you see x1 is equal to 20 by 7, x2 minus 18, x2 is equals to minus 18, and in here 7 by 2, x3 is equal to 11 by 2. So in here it is cancelled, so x2 will be minus 1, and in here 2 is cancelled this one, and then x3 will be equals to 11 by 7. So this will be your final solution. Okay, so I will give you the solved examples of this one, and then you can practice more. You can practice for your 2x 20 by 7. Yes, it should be 2. Yes, you are right. It should be 2 into 20 by 7, and then it will go there. So maybe it will be 10 by 7, like this one. The answer should be like this one. Okay, thank you for correcting me. And then we are done with the 1, 2, 3. We are done with the 4 methods of finding the x2 should be positive 1. Yes, x2 should be positive 1 as well. Okay, yes, this is minus, so minus minus is also cancelled. It should be plus 1. Yes, let's go to the previous this slide. Okay, so okay, you can see in here. Okay, I will also give you the solved example in the notes. So I will just upload it in the Canvas after the lecture today. You can practice. There are several examples. You can practice it. Okay. So let me see if there is any other example that could be. Okay, so let's talk about the our studio now. So let's take 5-minute break and let's meet again in what is time in Philippines? 3, 4. Let's meet at 4 p.m. Okay. So we will have 7-minute break and let's meet again. Bye.